So this is Hacking .NET Applications at Runtime. I'm Jon McCoy, and this is Daniel DeFries. So going after .NET at Runtime is using reflection to activate the functionality inside of a .NET program. This is legitimate inside of the .NET framework. It's functionality inherent. This is part of a runtime language. If you go to something like Java or other intermediate languages that have CLR, you'll find this basic same functionality. This allows us to reflectively look at objects and edit them at runtime, and we're going to exploit this to make a .NET application malleable, to not only change the value and state of it, but to literally change the logic flow. We're not going to be attacking code, we're going to be attacking the runtime itself. So this presentation will be covering accessing running .NET programs, attacking the runtime structure, the weak points to go after when you attack a program, and some tools that we're going to be releasing. So the tools that you'll be getting is .NETisploit. This is a framework and payload system with a management area, as well as the standard deliver, package your payloads. So it's easy to reuse, and hopefully people want to develop for it. Metasploit payload that'll work with the delivery system that will be arbitrary. And this will be a standard Metasploit delivered to SQL Server Management Studio. And we'll demo that towards the end. Hopefully you'll like it. And we also found some really nice extras when we were doing this research. We're going to be leveraging an old Visual Studio's exploit, as well as showing some decompilation that'll get around some of the protection that you might run up against when you're trying to decompile .NET applications. So the runtime attack. It's going to go after the process space itself. This is your application. You can put more than one application in a process space. We're going to modify the runtime objects of a process to carry out this attack. We're going to be editing the underlying structure of an application, the structure itself, not the code base. This will allow us to compromise the GUI, instantiate new features, access the code base, subvert logic, and evaluate the object structure. Evaluating the object structure is more for reconnaissance. When you get into someone else's application, assuming you do or don't have access to their source code, you want to go around and figure out how those objects lay in memory. What instance of an object do you want to attack? This is also useful when you're attacking a program live. So if you're not making an out-of-the-box attack, you want to attack it on the fly. This is also useful. So what is it and what is it not? This is a memory-only attack. We're not going at it on disk. This is deployment independent. That means that whatever way that you are able to make it into your target's runtime, this attack will be carried out the same. We have a few demonstration ways of getting into your target's application. And stability. We're not playing games with the heap. We're not messing with pointers. We're inside of the .NET framework. So we have the stability that .NET comes with. You don't have to worry about accidentally changing one thing that changes everything else in the program. And this is language agnostic. When you're attacking a .NET program at runtime, it's IL, so you don't have to care about what language it was coded in, as well as you should be going up against protected programs, which will have obfuscation, so you shouldn't be able to convert it back into a language anyway, so it doesn't matter. So this is what we're attacking, a .NET process. You have app domains, assemblies, modules, classes. This is kind of the structure. At the end, we have our instances, and this is what we're going after. So this is the classical view of a .NET process. You have a process where you have your GUIs and your instances. Inside of that, you have app domains, assemblies, and eventually you have your classes and values and functions. And this is our target. We're going to be going after instances at runtime. We really don't care what class it came from. We will be utilizing what class it came from, but the structure of the application doesn't matter. The structure of the objects matters. And this is what a program kind of looks like at runtime. You'll be going up against a lot of objects spinning around in memory. We have logical sections like the GUI and the core functionality. These objects are interrelated by pointers behind the scenes, but basically value references. And we have a button. It's interconnected by an event to a specific object. And this is our target, to go after the runtime, to go after the instances, to go after the events, and remold all this. And this will allow us to change the underlying structure of a .NET application. So the specific task behind this attack, going to connect into your target application, find objects, and hunt for the references to the specific object you want to attack. Like if you're going after a timer or a SQL connection or a TCP connection, you have to hunt down your references in order to attack it. Going to move between objects. Depending on your connection method, you might need to hunt objects. Other connection methods will give you references for free. And finally, we're going to change objects. Using reflection, we'll look at the metastructure of an object, use its signature, and edit it at runtime. Okay, so down to the meat of it, how do you get into your target application? So you connect into your target's runtime. You inject into it and spin up some .NET. There's some projects we'll be demoing for this, and is the favored method for injecting, or for connecting to your target application. This is what we're going in with Metasploit. This is how you attack them on your system. Also, you can exploit the target's code base, or the problems inside of the application. We're going to be demoing Visual Studios and exploiting that. Both of these get you into a target application, not necessarily where you want to go, but it gets you inside. There's infecting the target's code base on disk. This is an old hack. You find your entrance, you add yourself into a no-op or something, and you're in. That's kind of been done. This is on disk, so you're going to leave some forensics evidence behind. As where with injecting your code into memory, you're not going to be worrying about leaving something on disk that can be recovered later. And finally, there's attacking the framework, where you infect the framework itself. This was presented last DEFCON and has a little bit of research behind it and is pretty strong. When you infect the framework, you don't have to worry about the target application seeing your code running inside of it. You can access core things like toString, and when someone uses it, you attack them. So you can basically have an entrance into any application that uses the framework, which is all the .NET applications. So, demoing how to connect into a target application. We'll bring up Mandiant's highlighter. Going to be injecting a 64-bit payload in there. If it's a 32-bit application, you inject a 32-bit payload in there. So we inject in, and this spins up a payload that says, what do you want to load in? We'll select hack buttons. A nice little demo that goes in and it adds objects to the form itself. And it's pretty easy to go in and edit forms since they're made to be fairly receptive to new objects. And we can click these buttons and they go through and add events programmatically to everything it finds on the form. In this case, it adds a right-click event to everything on here. When you right-click, it brings up an editing menu. And so you can edit pretty much anything as you normally would. This is pretty much the same concept as what Visual Studios does when you're editing it offline. And you can dig into pretty much any part of this and edit it however you want. And of course, you can do this programmatically to reskin any application. And there's some other ones, like you can make them draggable and all that. Make them poppable, but this is just a demonstration of the injection. So that's injecting, demonstrating the exploitation. We will, as a quick exploit for Visual Studios, there's a way to run arbitrary code inside of Visual Studios when you open a project. So we opened a project and now there's arbitrary code running. So we'll again say, hey, what payload do we want to load into this? And we'll load the leet. So this just programmatically goes through and changes everything into leet. Haha. So this is actually .NET form. It's alive. It's actual objects, and we're going to lead it. Part of this system is a communication console with all of the payloads. So we have our delivery system, we have our leet, what application it's in, the PID, the user. And this will hopefully be extracted to run over the network So you can arbitrarily communicate with payloads that have been deployed on someone else's system. So we'll go ahead and lead Visual Studios. We'll also bring up a data connection. So we lead it. It comes through, it iterates through every object that it finds that's of a control type and changes its text to lead. And this actually happens in code. So the plus side of this is it's completely programmatic, and we don't have to worry about disturbing the underlying structure of the program. And also, FYI, if you save this, it actually saves Elite into your code base. And that's exploiting that. So that's the general connection types. There's also infecting the framework, which I'm not going to be demoing, but there's some code base that we're going to be releasing to do that. Like I said, it's pretty strong and pretty effective. So this is the overall structure of the application, or the system. You have your payloads. They get packaged into a safe wrapper that gets injected into your target application, so you don't have to worry about threading or any other hiccups when you're running inside of another application. And you have your injection into your target application. So this is the basics for how we're getting in. We inject into our target application. We spin up some C++. This unpacks itself in memory and spins up C#. This can either be your hack or your payload delivery system. At this point, it loads up our arbitrary payloads, and they attack the target application. So this is the basic idea of what you're up against when you inject into a target application. You basically end up in nowhere. You have no references, and you have no way of getting to your target application. You can hope to get some statics or some entrances, APIs, or some object reference, but on a whole, you're pretty much in the middle of nowhere. So how do you get from the middle of nowhere to your target application? There's nothing stopping you, but there's also no doors to use. So the favored method that we're going after is accessing the GUI to turn that around into an object. You say, Windows, give me a handle to the window, and then you ask .NET to turn that handle into an object. Once you have the Windows form that you want inside of your target application, you can iterate inside of that through all of the controls, access all of the events being function pointers to your target objects. And once you've done this, you can iterate through the object structure using each object to gain more references until you've either reached your target object or you have exhausted the entire object structure. And that's how you get around into the object structure. At this point, once you have all of the references, it's pretty simple to implement your changes to your target application. So, as a quick demo for mixing the GUI, we'll spin up Redgate's memory profiler. We'll inject into it. And the nice thing about this is basically any .NET application is susceptible. Once you're in, there's nothing that can really stop you. There are a little bit of tricks that can be played inside, but I'll get to that later. So we're inside of our target application. We'll load up our hack buttons again, and we have a payload inside of our target. Utilizing our communication paradigm, we can say we want to load another payload in there. And so instead of picking from one of the payloads, we'll actually load another .NET application into it. And this is .NET Reactor, a code protection system, itself being protected by a good number of obfuscation, shells, everything that this protection system could throw at protecting other .NET applications. So we're injecting one application into another, and at this point they're essentially becoming one application. They're in the same app domain. They're not sharing logic flow, but they are one application now. And so now we can say, add yourself to that form, since these are all one application now. Ants Memory Profiler and Reflector. And again, we can go